Okay, limits with radicals can be tricky. The first spot where this specific problem can be tricky is that you know, because the limit's going to infinity or negative infinity, a bell goes off and you know that you need to multiply by 1 over x to the highest power.
Yeah.
Top and bottom, right? Here, though, what is the highest power is actually tricky.
Yeah.
Okay, so you were about to say?
It's actually 1.
Right, okay. And why is it actually 1?
Because even though there's a nx squared on the bottom, but because of the square root sign.
Right. So essentially we're thinking, the square root of x squared plus 1 has a power of 1. Because writing the square root as a 1/2 exponent, x squared to the 1/2 is just x to the 1.
Mm-hmm.
Okay, so what we need to do is multiply by 1 over x on the top and the bottom. Okay, so we're doing the limit as x goes to negative infinity. Okay, and we know that we have to multiply the top and the bottom by 1 over x.
Mm-hmm.
Now, the next issue of trickiness is what to do with, how does 1 over x talk to the things under the radical?
It says, hello, my name is 1 over x. Hello.
And so, maybe so. Maybe that's what it does.
Yeah.
But in order for 1 over x to penetrate the defenses of the radical,
it has to come in as a Trojan horse.
It has to square itself.
Yeah.
Right? But in this case, x is negative. So we also have to account for that. So I'm going to skip to the next line,
Yeah.
which indicates the result, and then we'll talk about what happened. So obviously, in the top, x times 1 over x is just 1. Now down here, I'm going to write what used to be under the radical, x squared plus 1, and I'm going to multiply it by the result of having brought 1 over x into the radical,
So 1 over x squared.
which is 1 over x squared. But, like I said, 1 over x as a fraction, because x is going to negative infinity, is negative. Okay?
I agree.
And what we have written so far is positive, actually,
Yeah.
if you just look at it.
Yep.
We're not allowed to just up and change the sign. So what happens is 1 over x squared has to leave the negativity behind, if you want to make a, some kind of analogy to like only positive thinking under the radical. I don't know, whatever goofy thing you want to think of. There we go. Now this negative 1 would not have appeared if this was positive infinity. Okay, the rest of it's easy in the sense that now this is going to be limit x goes to negative infinity. I wrote negative 8. That's ridiculous. It's a sideways infinity. Negative infinity. In the numerator, let's go ahead and stack the negative 1 with the 1. In the numerator, the radical becomes...
Did you just say numerator?
1 plus 1 over x squared. Okay, give ourselves a little more space here. So, anyway, now it's easy because everything's a number except this 1 over x squared, which goes safely to 0, and that becomes negative 1 over radical 1 plus 0, which is a stupid way to write the number negative 1.
Yes.
Okay, and so that is a tricky limit with a radical that we dealt with by paying careful attention to, first, the power that we really have to multiply by, second, the fact that anything we move under the radical has to square itself before it can do so, and third, in the event that that thing was originally negative, it must leave the negativity outside.
Yeah.
Okay, so we got it.